Find the interval of convergence of the power series sum equals n equals 1 to infinity of 2x to the 2n root n, all divided by 2n factorial. We're going to use the ratio test. Now normally the ratio test has you dividing a sub n plus 1 divided by a sub n, successive terms. This is really not the way to write it out. What you should do is take the individual terms and give them each a fraction, replace the n's by n plus 1s. It's the fast way to get to the simplified version of that continued fraction. So when you have 2n plus 1, that simplifies. When you distribute across the quantity, that's 2n plus 2. And so that's our factorial. And then once again in the exponent here, we get 2x to the 2n plus 2. And then our root is the root of n plus 1. In the gaps, what we do is we take the original terms from a sub n, and they end up above or below the corresponding parts. Above the 2n plus 2 factorial is 2n factorial. Below the root n plus 1 is root n. Below the 2x to the 2n plus 2 is 2x to the 2n. And now we have to consider each of these limits, these fractions, taking the limit separately, but we'll use algebra to simplify first. When you have 2n plus 2 factorial, it's like having 7 factorial, where we take off a 7 and a 6, factor it out, and be left with 5 factorial. We take off a 2n plus 2 and a 2n plus 1 and be left with 2n factorial. For the 2x to the 2n plus 2, we break it apart to be 2x to the 2n and 2x to the 2. Now here's how we cancel. The 2n factorials go away, the 2x to the 2n's go away, and when it comes to root of n plus 1 divided by root of n, as n gets large, it's just going to go to 1. So what's left over is this 2x quantity squared, or 4x squared, and that's divided by 2n plus 2 times 2n plus 1. N is still getting large though. No matter what the x is, the denominator is getting very large. The larger the denominator gets, the smaller the fraction gets. In the end, this is going to go to 0. Now what are we doing? We're doing a ratio test to try to find the interval of convergence. So for the ratio test, it must be less than 1. Well, 0 is always less than 1. Doesn't matter what x is. We will always have convergence, no matter what x is. So x should be allowed to be anything. And the answer is that x is the anything on the entire real line. So whenever you get the ratio test giving you out a 0, when you're trying to find the interval of convergence, then you report your answer for the interval of convergence as the entire real line. There's no value of x that would cause divergence. Okay.